Like, how about right now? Let's solve problems today. Like, for example, Tom, he's got a problem. He invested $9,600. He put in a portion at 4% during the year. He invested the rest in a riskier investment. He got 10%. And his total earnings were $528. His question is, how much did he invest in each place? So, for example, suppose he put in $5,000 into the 4% account. How much did he put in the 10% account? How do you know? It has to add up to 9,600. Looks like we got an equation. A plus B has to be 9,600. Nice work. My daughter was doing some math the other day. She said, Dad, I got two variables. I said, well, then you need two equations. She said, what? I said, yeah, that's the way it works. One variable, you just need one equation. Two, you need two. Three, you need three. Four, you need four. So on and so forth. So I got two variables. I need a second equation. Can somebody come up with a second equation? It's got to revolve around interest, doesn't it? How much interest do I have? 528. So you got a thought there, Ashwar? Excellent. 0.04a plus 0.1b ends up being equal to 128. Or I'm sorry, 528. Great. I've got two equations. I have two variables. Now I can solve piece of cake upside down. You tell me. I got two ways of solving this. One starts with E, one starts with S. Elimination or substitution. I'm going to choose to use eliminate or substitution here. I'm going to say that B is equal to 9,600 minus A. That's what I've got. I'm going to put it right there. So I have a new equation. 0.04a plus 0.1 times 9,600 minus a is equal to 528. Y'all okay with that? I distribute the 0.1 and I get 0.04a plus 960 minus 0.1a is equal to 528. 0.04a and negative 0.1a would be negative 0.06a. Subtract the 960 over to the other side, we get negative 432. Divide by the negative 0.06. I get A is equal to negative 432 divided by negative 0.06. Because this is the third time that I've done the problem today, I know that the answer is $7,200. At what rate was that $7,420 or $7,200 invested at? At what rate? 4%. So then B would be what? Yeah, 2,400. Good work. Not too bad, huh? Well, suppose we go on down in chemistry class. Kessler's ready to blow something up. Okay. And she's got some acid. So we've got, let's use these two bottles here. So YouTube Nation, I'm doing a demonstration. Josie and Ashley are going to offer up these two bottles. We'll say that this Josie's bottle is 60% acid. That's disgusting. You shouldn't be drinking acid. I'll say that Ashley's bottle is 30% acid. And we're going to start to dump them together to form a mixture. It'll be diluted from the 60%. It will be more than the 30% because we're adding them together, right? We want to come out with 50%. Suppose we want 50% acid. Think we're going to dump more of the 60 or more of the 30? What do you think? We want 50 in the end. Dump more of the 60 or dump more of the 30? What do you think? More of the 60, right? If I would have said 40%, then we would need more of the 30 because it's closer, which side is it closer to, right? So we know we're going to need more of one, but how much? Well, we want a total of 300 milliliters. Who can tell me what my first equation would be if this is the amount of 60% and this is the amount of 30%? Give me the first equation. How much total do I have? 300. So the amount from A plus the amount from B has to be equal to 300. That's the total solution that I have. Two variables, two equations. Got to come up with a second equation. Second equation probably has something to do with acid. You want to take a guess at this one? What did you guys say at the end here? 0.68 plus 0.3b, but it's not equal to 0.5. So this is the cardinal mistake that everybody makes. I allowed you to make it so that you would take ownership of it and be able to see a better way around it. Notice that my representation talks about how much acid. We don't have 0.5 acid. We have 50% acid. 50% of the 300 is 150. You see that? So that could trick you on the test, couldn't it? You need to take a mental note of that and see how that works out. Well, now I have two options, elimination or substitution. I'm going to choose elimination in this one to teach you a different way. I'll multiply through by a negative 0.3. I get negative 0.3a minus 0.3b is equal to negative 90. I will add those together. 0.6a and negative 0.3a brings me to 0.3a. And 150 and negative 90 makes 60. Divide by 0.3. 60 divided by 0.3 is 200. So 200 milliliters of 60% acid. So how many milliliters of 30%? 100 milliliters of 30%. Good. I remember being in chemistry class in college, and I was not very good at chemistry. When chemistry questions would come up, generally people would not look to me for the answers. But we were in a lab and we needed to do math computations. All of a sudden, I was all their best friend. They were like, Kevin, how do you set this up? I'm like, you guys know how to set this up? And they're like, no, we don't. It's like, well, that's interesting because I don't know how to do chemistry and you guys don't know how to do math. So they tutored me in chemistry. I tutored them in math. All worked out. John and Eric, they're painting houses. Anybody have a house that they paint? Nobody? Yeah? Got a house you paint? You paint a house? Okay. Okay. All right. Because it used to be that everybody had siding that you painted, and now we have permanent siding products. Like I'm building a shed right now where I have vinyl siding, and so you never have to paint it, right? You're done. But I used to be painting a lot of houses. College kids would get jobs painting houses all summer. I mean, that's what it used to be, but not anymore. But anyway, John can paint. Eric can paint. John takes 32 hours to paint a house, and Eric takes 24 hours to paint a house. How long would it take them to paint a house together? 28, right? Just the average, halfway in between. Why is 28 an absolutely ridiculous answer? Eric can paint faster on his own. Right? For crying out loud. I mean, Eric can paint in 24 hours. Like you're doing the problem, you're sitting on the test. You're like, oh my gosh, I'll average them. You get 28, and you're like, and to you, you're thinking like, well, I average them, so that sounds very mathematical. But you fail to look at it and say, why would that work out at all? Like that's absolute ludicrous. Forget it. So I remember the first time I saw this problem, I said, well, yeah, that sounds like a really difficult problem. So I try to come up with a reasonable thought. I was like, well, I want to come up with a guesstimation. Okay. So suppose John took 32 hours and Eric took 32 hours. If they both took 32 hours and were working together, how long should it take them then? 16. Suppose it took both of them 24 hours. How long should it take them together? 12. So I said that because one of them's at 32 and the other's at 24, they should be somewhere between 16 and 12. So I guesstimated 14. Okay? Do you see how that's a reasonable thought? And I could give you points for that on a test for trying to think through that because that's reasonable. Heck of a lot better than 28, isn't it? Yeah. Okay. All right. Well, I think that this is what we refer to as a rate is equal to distance divided by time problem. Only if we multiply both sides by t, we get rate times time is equal to distance. And instead of distance, I'm going to put a W. W standing for the amount of work that gets done. Okay. So, for example, if John, instead of having 32 hours, if he had 64 hours, how many houses would he be able to paint? He'd get 2 of them done, right? Okay, so the time and the rate and the amount of work getting done is all related to each other. I know this. If you take John's work and add it to Eric's work, that total work adds to one house that gets painted. You know, maybe John does 60% of the job and Eric does 40, or maybe it's the other way around. But we'll figure how much of the job each one does. Well, fortunately, we've got a nice equation here. It says that the rate times the time is equal to the amount of work getting done. Well, we know John's rate. John does one house every 32 hours. Now, we don't know how much time it takes him when he's working with Eric. But we know the rate, that's the rate that he's working at when he's putting in that time. What is Eric's rate? 1 over 24. And again, times t, because we don't know how much time it takes them working together. And that has to be equal to 1. Well, that looks pretty good. I could solve that. This is just t over 32 plus t over 24 is equal to 1. So I just have to find what? Common denominators. I'm really good with multiplying numbers. I think 32 and 24 both multiply to 96. What do you think? 96? No. I think so. So we get 3t plus 4t all over 96. That's equal to 1. 3t plus 4t, 7t over 96 is equal to 1. How do I solve for t? Multiply by reciprocal. The reciprocal is amazing. So powerful. 96 over 7. If I only knew what that was. Uh-oh, moment of truth. I hope I come out between 16 and 12. If I don't, then I'm going to look like an idiot. 96 divided by 7. And I get 13.71. Awesome. That sounds good. Now, it's very hard to check to make sure that that's 100% accurate. However, I do know this. It sure seems like it's easy to check to see that it's reasonable, does it not? Yeah. Flip it over, 2 more. Hi, welcome back. You're all done? Okay. Hi, welcome back. Good to have you here. Somehow Matt got himself into the problem. We don't need Matt. We'll just go back to John. Sorry about that. John and Sue, they can paint a house in 5 hours if they work together. If John can paint a house twice as fast as Sue, how long would it take John to paint the house alone? I want you to talk with your partner or those around you and try to come up with something intelligent about this problem. You don't have to solve it. Just try to come up with something, anything at all. And then we'll roll through it. Okay? Take a minute and a half here. Talk. What does that mean? So we're talking about things that we know about the problem now, YouTube Nation, and we've realized that this is complicated. So suppose John painted one house every 10 hours. Then Sue would be one every 20 hours. So if John was one every 7 hours, then Sue would be one every 14 hours. So if John was one every X hours, then Sue would be, oh. So we actually have some expressions here for their rates, don't we? This is exactly like the previous problem, is it not? Where we said rate times time will tell us the amount of work that we were able to accomplish. How many houses are we painting? 1. And so we know that John's work plus Sue's work is equal to 1 house being accomplished. Well, we just take the rate times the time. What's the rate of John? 1 over X times, how much time does it take them together? 5. You see, you guys, it's the exact same as the previous problem. It's just we're switching. Before we were given the rate, and we're finding the time. Now we're given the time, we're finding the rate. Plus, what? 1 over 2x times 5 is equal to 1. Or 5 over x plus 5 over 2x is equal to 1. What now? Common denominators. Multiply top and bottom by 2. So we get 10 plus 5 over 2x is equal to 1. Or 15 over 2x is equal to 1. Multiply both sides by 2x. 15 equals 2x. X is 7.5. Sweet. What does 7.5 mean in context of the problem? Is that John's rate or Sue's rate? Look at the problem. The problem will tell you. Where is X located? It's located right there. And you can see that's part of John's work. John does 1 house every 7.5 hours. You look back at your work to determine what the answer actually means. So yes, we've answered the question. How long would it take John? 7.5 hours. If we ask Sue, what would you do? Double it. Oh, all right. Josie's just going to say she's right. Josie, we believe you. Okay, good job. Last problem we do for the day. 2 planes flying toward one another. One's going from Los Angeles. That's where Mr. Olson's from. He taught in Los Angeles past like 10 years. And then New York. Another one's going from New York. And they're flying towards each other. They're 2,450 miles apart. The one from LA is traveling at 500 miles an hour. And the one traveling from New York is traveling at 650 miles an hour. So it says, how long have they been flying when they meet? Oh, boy. Would you agree that this is a rate is equal to distance divided by time problem? I mean, you got rates and distances and stuff. I'm going to need a volunteer in order to work this out. Somebody want to volunteer? I need somebody. Who's my volunteer? Okay, YouTube Nation, we've decided that as the planes are traveling towards one another, their rates are not the same because one's traveling at 500, the other's traveling at 600, 650. their distance is not the same. Obviously, the one flying from New York is going to travel farther, but their times are the same. So if I multiply both sides by t, I get r times t is equal to d. Divide by r, and I get t is equal to distance divided by the rate. Now, there are multiple ways to set this up. And some people watch the video right now, you might be saying, hey, you could show them an easier way to do it. Fine, whatever. I'm trying to show ways to do it that you can apply to many situations. And deciding which ones are the same is really helpful. So I'm going to say that their times are the same. And so I'm going to set up the distance divided by the rate and set them equal to each other. What's the rate of the first plane? 500. We don't know how far he traveled, though, do we? We don't. What's the rate of the other one? We don't know how far he traveled, do we? Well, that's what I got to figure out. We'll call this one x, so I can put an x there. That looks really good. But the other one, what should I put for the other distance? A lot of times people put y. That's fine, but that's not going to help me. We need to get rid of a variable. We want just one variable. We need something in terms of x. Oh, there she goes. Look at her go. She says that whatever y was, you would subtract it from 2,450 to get x. You see that? Does that make sense? Yeah, so now we could just cross multiply. 500 times 2,450, because this is the third time I've taught it today, I know that 500 times 2,450 is 1,225,000, and also because that's my bank account balance. And that's minus 500. Stop laughing, Josie. I'm a rich man. And that's equal to 650x. Solve for x. I add the 500. I get 1,225,000 is equal to 1,150x. Now I'm going to take the 1,225,000 and I divide it by 1150, and I get 1065.22. What does x represent in the problem? Can somebody tell me what that 1,000? Yeah, you just look where x is. It's right there, 1,065.22. That's the distance that it's traveled. Is the problem asking us for the distance? What's it asking for? Time. Well, time is simple. Time is just the distance divided by the rate. So I'd take 1,065.22 divided by what's the rate? 500. I get 2.13. Sweet. Good work. You get a chance now to practice on your own. Question? And what you're going to do is this, okay? 1 through 11 on the front, you got that, right? And then 12 and 13 are totally doable. 15, 16, and 17 are totally doable. 18 and 19 are totally doable. So here's the deal. Which one did I leave out for today? 14. I told you, what's it like to encounter a problem that hasn't been modeled for you? 14 is that problem. I did not model it for you. You don't have to do it, but I would highly encourage you to try to figure it out. Might take some of you 10 minutes. Might take others an hour. Might take others 5 hours. Might take you a couple of you a few days. I don't know. But are you willing to really try to struggle through problem 14, figure it out on your own? It's your chance to show some ingenuity, something I have not shown you already how to do. See how elite of a mathematician you are, okay? All right, good work today.